Hello everyone, this is Mainak Choudhury. So we are going to design an industrial truss using Etabs, and also we will complete all the steps using the IS code. So without wasting any time, let's get started. So first of all, this is the truss which we want to design, but since we have had some time and there are some time issues, so we'll just design a small part since the structure is in symmetric anyway. So the truss dimensions will be like this. We have the truss dimensions. It is 11.7, and the maximum height of the apex is 1 point. Around this is 2 meters. So we'll take 2 meters, and this will take 11.7 meters. And we'll design the truss here for this span. And as you know, the unsupported length is around 11.7 meters. So the total it will be around 22 meters truss here. So I'm planning to divide this into 5 parts. It's around 10 meters, so each part will have a little bit more than 2 meter distance between them, and then we'll let's see how to do this in the Etabs software. Okay, so we'll apply wind load, earthquake load, and both of them, and we'll also try to use the IS codes for the respective things. So let's get started. File, and we'll just let me just click on new model, and I always encourage all of you to practice along with me, because there's no point watching if you don't practice. Just you can slow down the video if I am going a little bit fast, so you can just practice along with me. So you're using the custom grid spacing here, and here let's see along the x-axis how much we need here. So the x-axis is this axis. We need 3 grids actually. So let's go ahead and delete one grid here and delete. So we have actually 3 grids left in the x-axis, and the spacing here it will be around 11.429. So I'll go with 11.5 here, 11.5, and this also I'll go with 11.5. So I'll just press 11.5 plus 11.5 and do the calculation. Okay, so these grids are ready. Now let's go for ahead and put these grids. So in the y-axis we'll take let's say we'll just delete this. We'll take 3 grids to just make this pretty much symmetrical structure thing. So there will be n grids. There will be one design. I think the mid center grid will be another design. So we can pretty much give the design to the remaining structure here. So the y coordinate here, this will be this spacing here. This is around 5.486. So it will be, let's take 5.5 here. So 5.5 and is equals to 5.5 plus 5.5, enter. This will be 11. So this is done, and we'll click on OK, and let's now go for the custom story data. Here base is at 0, and these I'll name this as the plinth level. So plinth level will be at 0.45, let's do, and then the next level, the spacing the spacing will be 10 meters, and the next spacing will be 2 meters for the maximum height of the truss. And we don't need this. I'll just delete this story, delete structure, delete the story. Yes. So and to call it the apex, you can call it anything, and this story 2 apex, and then this, click on OK, and then click on OK. So the grids are ready now. So it will work here on the grids. So if you can define something, so probably we want to go with ISMB sections here, and okay, so we want to define the material properties here. So firstly, just if you double click also, it will this is the steel here. So I'll just name it FE250 here, and this will be steel density. You can check this ratio, you can check, modify this properties, FE250. This you can insert the properties here as you like here from the recommended codes here. So I'm going to go with the default properties. So by the way, most of the time we'll need this only these 2 properties here. So the bottom 2 properties are not needed. So you can check and insert these properties, change these 2 properties if needed. Okay, so going with the default here, and then click on OK, and then click on OK. So then we go to define and section properties, frame sections, where you can see there is ISWB section default available, but there are no ISMB sections. So we'll just import some ISMB sections here. Go to the Indian code, you can select your country code. We're designing all by the Indian codes here. FE250, just a grade here. And then in steel white flange you will find actually the Indian sections here, ISMB sections here. So I'm just going to take ISMB 450, okay, and also just going to take ISMB whatever I took, 450 I took, ISMB 300 also I'll take, ISMB 600 also I'll take the maximum one, ISMB 600, 550 also, and I'm just taking this whichever comes, will just the design 6, this WV, right? Okay, MB, I'll just want the MB 600, ISMB 600, and I also want ISMB 350, ISMB 350. Okay, I think this is enough for now. Now let's go for the box sections here, for the purlins here, 72 into 72 into 4. This is for the purlins. Now click on OK. So selected our sections here, and now we are going to go ahead and complete the definitions, because if you've seen my videos, I like to complete my definitions first. So in the mask source, just double click here, modify. I like this specified load patterns thing, and add and live load, and live load, let's take 0.5% in the seismic mass. Okay, and click on OK. So mass source for the seismic loading has been defined. P load, delta loading model cases we don't require in this one. Load patterns, dead load, live load. So now we'll add an additional load, which is called the seismic load in X direction, and this is automatic seismic load. And you select the code. I don't have the latest code along with me because my version which I'm using is old. So you better select ISO 1890 2016. So I'm not using the old version, so I'm using this 2002 here. No problem in that. And seismic load in Y direction. So instead it is Z direction. In Etabs it is Y direction. You can see these coordinates are interchanged. So this same coordinate system you find in AutoCAD, in Etabs, but in STAAD, Y and Z are interchanged in the default. Actually you can change in STAAD also. Okay, so X and Y here, and then we want to go W wind load in the windward side. I want to call windward. Okay, windward W wind load. Okay, and this will be obviously wind, and we have the latest code as of this current date 2015 along with us. So add new load, and I want to add a leeward. So sorry, I shouldn't name this. I should name this 0 degree and 90 degree. 90 degree wind load. Add new load. Can I change this? I'd rather delete and just 0 degree wind load here, and add new load. Okay, 0 degree and 90 degree, the two directions. It will I'll apply on windward and leeward faces for the walls here. Okay, so all done and good here, and dead load, live load, seismic load, and this are done. So I'll edit these loads here. So not go into codes. You can check the codes here. For this X direction, I will not consider eccentricity for this one. Obviously, not consider the Y direction as well. Our structure lies in seismic zone 3. So the factor will be this one. This one is for 5, this one is for 4, this one is for 3. You just check the code 16, and here now this is structural type is 2, importance factor is 1. Actually industrial factor buildings, it is better if you take 1.5, and response direction factor also. Let's just check here what does the code say actually before making an assumption. So in the table number 9 of the IS 1893/2016, it says that for the steel building and with ordinary moment resisting frame. So if you consider ductility in steel building, then it will be 5, and if you don't want to consider ductility, you should consider 3. So let's not consider ductility in this one. This is in zone 3, and by the way, you can check whether ductility needs to be considered or not in steel. So and importance factors. So important buildings, community buildings, governance buildings, schools, hospitals, exchange, television stations, radio stations, any mention of warehouse, metro stations, metro rail stations, railway stations, fire buildings, cinema halls, shopping malls, assembly halls, subway station. So there is no mention of warehouse here. So we are designing an industrial warehouse. So so we'll consider 1 here. Factor of safety importance factor is 1, responsibility factor is 3, program calculated, and the bottom story will be the plinth level, obviously, for all seismic loads, and time period we'll let program calculate here. Similarly, we'll do for this direction, y direction also. Do this and make this as the plinth level, and response reaction factor make this as 3, and this we make them as 0.16 here. Importance factor is 1. Let the program calculate here and then click on OK. So seismic load in x and y direction are defined. Now let's go the wind load. So wind load is a little bit typical, but let's see. So first of all, we use exposure from shell object because we want to apply the loads on the roof panel of the truss, and by the way, you can also apply on this main building itself, but you can comment below whether you want to see that. Okay, so exposure from shell objects is selected, and these are the things which we need to consider. So our structure is in Lucknow. So here we need to check the basic wind speed of Lucknow. So in table number annexure A, you can find the basic wind speed for Lucknow is 47 meter per second. So first of all, straight ahead, go and enter the 47 meter per second here, and then the terrain category and everything will just show you. No worries in that. Let me just open the Excel file. In the other videos also I've given the link for this file. You can download this. If you want, I can send again. If you ask in the comments, I'll send again also. In this, the first of all, the probability factor, which factor do you want? The K1 factor. So for the K1 factor, you have to check here. Can I delete this now? Close this now. Okay. So K1 factor checks page number 10 here. Let me just check page number 10. So this is a page number 10 of the PDF. If you have the PDF and soft copy, then it is page number 7. Okay, so in page number 10 or page number 7 of the printed copy, you'll find the K1 factor for all temporary sheds, buildings with low hazard, and for all generally buildings it is for the 47 it is 1. So 47 is our basic wind speed, so it is 1. So we'll take this value, which is 1. So go ahead and put 1 here, and then you have K3 factor, which they are asking, and then the terrain category also will come here. Okay. So K3 factor is in page number 11. So we'll put 11 here and enter. So K3 factor here, here you can see where it is the K3 factor. Okay. So if your structure has a slope of more than 3 degree, up to 3 degree, then K3 can be taken as 1. And if you have a slope ground, then you have to interpolate between these values, and there is a table, separate table which is given in this code. But our structure is on level ground, so most level grounds have up to 3 degree slope or less than 3 degree slope. So we'll take K3 factor as 1. So we'll go ahead and put the K3 factor as 1 as per this particular clause. Now comes the terrain category. So terrain category also you will find in this. Actually, it is divided in page number in the printed version. It is 6 to 8. It is divided here, and you can see if your structure is in a densely located area, it is category 4, and if your structure, then it lessens. But structure terrain category 1 is an open structure, and which obviously the open structure will have the maximum wind load. So let's consider terrain category 1, okay, with no obstructions. Okay, so the average wind load will be more here. So this is these open parts and underdeveloped parts area. So this is an industrial area, so we're going to consider terrain category, we can consider 1 or 2. Let's consider 1 here. Okay, so terrain category 1 here, and then click on OK. The same thing we have to replicate in this one. Modify lateral load here, 47, terrain category 1, importance factor of 1, K1 factor 1, K3 factor 1, and the K2 factor actually depends on the height the software will calculate itself. And this will be the plinth level, and this will be exported from shell objects, and click on OK. So our wind load is done, but after clicking on OK, I advise to go to define again and go to load patterns again, because sometimes this, if you forget to click on OK, this might vanish. So it's better to check. So that's why. So all loads combination have been defined. as usual, you have to just prepare particular set where you can remember all the steps here. So that's why I'm just going through the define first, and then I'm just doing the remaining things. Okay, so we have this grid. So let's come back to modeling here. We have done some different definitions and something. These are the grids here, and this is the apex here. So we'll come to the story below, and always remember that we cannot assign columns at other levels other than the plinth level. So if I want to assign the columns at the foundation level, I can't. So just take the quick columns, and we want to start with let's say ISMB 600. Well, let's start with 450 itself. 450, and assign the columns here like this, and you can see this is up to plinth level they have considered. Go to the level above and also place the columns like this. So our columns have been defined to the portion where we want here. Now we want beams also traveling through these like this here. So we want here ISMB. Okay, let me just select quick draw beams here, and we'll select the ISMB 300 for the beams. Both the option I have taken, I think 300 and 350, or both the option. No, 300 I haven't taken. Okay, let's just define section properties, frame or tendon sections. Just clicking wrong. Section properties, frame sections, import new properties. MB 300 I want here for the beams. MB 300. Okay, if this fails, then we can just revisit again, right? So ISMB 300 goes for the beams, not WB. I want MB. Had I selected WB here? Okay, I think I selected WB by mistake. Okay, yeah, I have done B, sorry. Yeah, so here I want to apply this beams like this. These beams I want to apply like this. So along this this vertical portion of your screen, this you will have the truss, so you don't want to overlap, so that's why I'm not applying along this portion here. So this portion is done. Now comes the part of the truss. So the truss will be applied. Oh, sorry, I have applied the wrong direction. It will be applied in this direction. Sorry, I use Ctrl plus Z to erase this, and again, because truss will applied in this direction, so my beams will be applied in this direction, right? Okay, yeah, this direction. So in this direction, in the horizontal direction, we'll have the truss here, so I'm not applying this. So yeah, escape, bit of something. We'll just take the one elevation part. So select this, select the elevation one, apply, and okay. So so for this roof truss, you can go with angle sections here, I sections, ISMB sections also. We can go. Let's try ISMB 300. Let's try ISMB 300 here. I can try lower side also, but let try that later. Select this, and here ISMB 300, something lower also I can go, I think, but okay, let's try ISMB 300 for the bottom and top chords, and for the internal members we'll try something else. Okay, bottom, top chords and apex I'll do this one member, and for the internal members, other members, we'll do something else. So this is selected here, and this point and this point. So right click here, left click, left click, left click, outside, right click. Okay, like this. So these members are made here, and for the internal members we'll try something else. So for the internal members we can go with let me define some section properties for some lower size members. Import new properties. Usually you go by angle section in this one. Since we're going with ISMB, let's go with ISMB 100. Okay, let's see, ISMB 100. Okay, now for this I want to divide this into 5 parts, since there will be each part will be 2 meter or a little bit more. So edit frames, divide frames into 5 parts here, click on apply and then click on OK. Okay, and then I want to select this and I want to select ISMB 100 here, and here I'll get the joints here. So make sure this angle which you have is 90 degrees here, 90, enter, right click. Okay, don't worry, we'll just solve it later because I am here. Okay, don't worry. Just make this sure, making sure this is 90 degrees, right click, left click, here go 89, 90, left click, right click, right. So here this one I'll join this like this, right click. So this one, and select these, this one remaining, go to edit, go to here, edit frames, divide frames, break at intersection, apply and OK. So now this will be separate with this one, and you can delete this. Okay, so yeah, I have, there's a grid here, so to do repeat the same step again with the smaller parts, and this and this is selected here. Now we'll do the same thing, edit, edit frames, divide frames, break at intersection, apply and OK, and then select this, select this, select this. Oh, it's not breaking. Okay, so let me just try again the step. I think I missed something. Okay, select this, go to edit, edit frames, divide frames, break at intersection visible. Okay, this is not, there is no grid line here, intersect. Okay, let me just check again. This is not being divided here. Okay, let me just try something else. It should work. Maybe again. So this is not acting as an intersection, right? So that's why it's not. Okay, let me just check here. Okay, sorry, I found out I selected the wrong option actually. This should be the members actually. Okay, so what should we do? Just select this here. In the first time only it should have been done because I've selected wrong option. So select this and show you which wrong I've done. Edit frames and divide frames. Instead of using this option, we should use this option like intersection, selected frames and join. So that's why it didn't occur in the first place. So in the one try we could have got this, but we didn't. Don't make mistake like me. That's why I'm showing you, just so that you can know which mistakes you shouldn't do. Okay, right click and then left click, right click, left click, right click. Okay, this looks good. Now I want to select all these things, and I'll join them. Go to edit, edit frames, join frames. Like I even want to join this one also. Edit. No, let this join happen because I want to kind of mirror this. Okay, so let's see if I can mirror this. Select this, select this, select this, select this, and this, and this, and this, and then we use Ctrl plus R shortcut for replicate. You can also go to edit and find this option. So use the mirror option and pick 2 points in model here. So I'll pick this point and then pick this point. Then before applying, you can just hover over and see. You can see when I click on apply in the right portion of my screen, this appears. Just click on apply and you'll find this very interesting. And then now you can join this actually, but let's complete the purlin first. So for the purlins, we'll select purlins and sheets also we'll do. Select this, select this, select this, this, and this. there our purlins will go here like this. So we'll use the option of edit and extrude from join to frames. We want purlins, so we'll use this one. For sheet we'll use this one. So frames, this one, and the extension will be in the y direction, I guess, and the distance here which we've taken, I think we've taken 5.5. So 5.5 in the y direction, and there are two steps, so one step, two step. Okay, apply. I think this is okay, yeah. And then then I want to select this and join this, because there's no point now not joining them, because I don't want separate frames. Edit frames, join frames. So this is a single unit now, and let me check this one is also a single unit. Okay, so now this will be easier to copy for me, and also easier to make the sheets also. Select this here like this, and in 3D also I'll check whether the right things have been selected here. So I'll go to Ctrl+R, that is replicate, and number of steps is 1 here. Okay, and I can no need to use pick steps on model, I can use a linear option. Let's go number of steps 2, and the spacing, you know, this is 5.5. so y direction 5.5, and then click on apply, and then click on OK. So this is done. Now for the sheet portion, so select this and select this. Now click on edit, and then click on edit frames, not edit, sorry, extrude and extrude frames to shells, and y direction, and the spacing is 5.5 in the y direction. Number of steps is 2, 5.5, number of steps 2. Click on apply, click on OK, and this is done. And but now we haven't defined the property of the sheets as well as the purlins. So the easiest way of selecting the purlins is you go to the plan. I want to open the plan in this window, so select this window and click on the plan here, and the base, let's close this, and we'll go above here, this level. So the purlins should be this should be the purlins here. So just select the purlins here, this level. Go to the next level here and select purlins like this. So you can see, nice and good, we have selected all the purlins. Now we can go to assign frame, section properties, and what are the properties which have defined for the purlin. This is a 3 inch into 3 inch into typical it's very 4 centimeter, 5 centimeter, 5 mm, sorry, not centimeter. So this is the thing, and then click on apply, and then click on OK. So purlins have been defined now for the slab. Now there's an important concept here. For the roof panel, you have to apply the loads according to the roof panel. Like, you may use asbestos sheets, so you can refer to IS 870 part 1 for the loading. In this particular project, we're using simple simple sheets here with thermal insulation, and it's called PPGL sheet. Okay, PPGL sheet, and I have calculated the PPGL sheet based on the data found on the company's website, which I have purchased. So it is 0.35 kilonewton per meter square. So I'm going to use that load. And also another important concept is that should be used as a membrane, so this doesn't take any bending, and all the loads get transferred to the purlins, so that we can design the purlins properly. Okay, so this sounds a very complicated thing, but it's actually a simple thing. We're designing the purlins, all the loads are going to the purlins, we're not giving any load to the sheets. Okay, so this simple thing to happen here, and so I'm going to just go here and go to define here, section properties, slab sections. By default everything will be put in the slab 1 here. So if I edit the slab 1, then it's okay. I'll just do PPGL sheet, and slab material here. You can use any material here because you have to use one material here. Okay, doesn't matter. And I just use a very small, this is RCC, by the way. It's very small size, 0.01 mm. Just so the load self weight is negligible, and I'm going to apply the dead load as a load. So make sure this will be membrane so that it does not take any bending. Okay, and then click on OK, and then click on OK. And if you want to check whether this is slab section or not, just click here and right click here, and then you can see this is PPGL sheet which you've just defined. So we are okay, good to go. And yeah, what else do we have? I think we have I've forgotten the plinth beam, so let me just apply the plinth beam also. And we'll also apply some load here for the plinth beam also. There will be 10-inch 3-meter wall, so we'll apply the load of the particular wall on the plinth beam on the only the outer sides, not on the inner sides. So let's go here below to the plinth level. Here, this is the plinth level, right? Yes, this is the plinth level, and here we're going to go and select this quick draw beams. ISM 300A is enough. These are the plinth beams. Okay, so now first of all, let me apply some load on the plinth beams. 3-meter 10-inch wall. If you want to calculate the load, just open your calculator. I'll just show you roughly how to do this. Sorry, and 0.25 10-inch wall into 3 meters into the unit weight of brick and plaster, approximate unit of brick and plaster 20 kN per meter square. Enter 15. So we'll apply loads of 15 here. Okay, so we'll just select this, and I'll go to assign and assign frame loads, distributed and dead load, and this will be load is 15. Okay, click on apply and click on OK. This is done. Oh yeah, so sorry, you need not apply any loads on this particular frame and this particular frame, as there will not be any load here. Okay, so we'll go to assign frame loads, distributed, and use the delete existing load option, apply and OK. So you got to learn this option as well due to my mistake, but you got to, this is all planned. Okay, it's all planned. So to teach you the how to remove this mistake. Okay, so now you have this plinth level loads assigned perfectly. Now let's go to the roof portion and apply some loads there. So if you look at the IS 1875, so if you have in the table of IS 175, let me show you, otherwise you'll say I'm not showing you this. Okay, here we are, IS 875 part 2 1987, and in this by the way, let me know if there is any updated these codes on this live load or what, but as far as I know, this is the latest code 1987. Apparently it should be revised, I think. So access provided, if it's access provided on flat or sloping roof, it's 1.5, and if it access is not provided, then it's 0.75, except for maintenance. Obviously there will be maintenance, so we'll take 0.75, and or if the sloping roof is greater than 10 degrees, then we have an elaborate formula for this. So what is our spacing roof angle here? It's around 10 degrees, so it's exact 10 degrees, so we're going to go with 0.75. So we're not going to use this formula here, 0.75. so greater than 10 degrees, right? Okay, so we are at the border. 0.75 we'll take the live load here. So for taking the live load, and that would already told you I calculated using the data for the material found on the internet. So I'm just selecting this. So the sheets have been selected here, and once the sheets are selected, now you go to assign and shell loads uniform. First of all, dead load, as I've told you, 0.35 I have calculated for the PPGL sheet which I am using in this project, so you can calculate accordingly, obviously. And okay, just click on apply here and then click on OK. Before clicking on OK, we'll just select live load and go to select get previous selection. So this is selected once again, live load, and then live load will be 0.75, obviously, for slopes up to 10 degrees 75, and click on apply and OK. Dead load and live load have been applied, and again go to select and select get previous selection, and this time we are going for the wind load, wind pressure coefficient. Okay, wind pressure coefficient. So go to assign shell loads wind pressure coefficient. Now let's apply for the 0 degree. First 0 degree windward. So if you select one phase as the windward here, okay, so this is coming, let's select this as a 0 degree along X, this is 0 degree. So if this is windward, then this will be leeward. Okay, so I'll deselect this these two because these are leeward here. So I'm select wind is blowing in this direction, so this is windward, and the opposite direction is leeward. So I have to enter the coefficient here as per the code. So let's check the code. So in the code, in table number 9, that is IS 875 part 3 2015, table number 9, you will find the code for the CP values for double slope roofs. Above this is single slope roofs for the mono slope roof, and this is double slope roof. So for an angle of 10 degree, which is our angle here, roof angle 10 degree, and the values are given here. So overall coefficient is given, and then you have the for this for 0 degree, this windward side and leeward side, these coefficients are given. So we'll apply these coefficients here. This will apply on the windward face, this will apply on the leeward face for a 0 degree, and same for 90 degree we'll apply this for the windward face and this for the leeward face respectively. You can apply in all in one also, no problem, but we'll do that. Okay, so first of all, in the windward side it will be 0.7 and leeward side it will be 1.8. so windward side is selected, so this will be 0.7 and click on apply. 0.7, good, pretty good. So now you select this leeward side face, and in the leeward side, as per this code, it is 1.8. so do this 1.8 and then click on apply. So 1.8 has been applied, and the direction is something which you can change here. So the wind is applying this in the windward side. If it is acting like this, then in the leeward side it should act on the opposite direction. Okay, so it should be, you can check this. I need to do some research on that also, the direction part. Okay, so now let's go for the wind load in 90 degree direction. So for the 90 degree, if the wind comes in this direction, then both this face is the windward face actually. This is the thing here, both this face is actually the windward face. We don't have any leeward face here. So now apart from the 1.4 and the 0.4, 1.4 is more, so I'll apply the 1.4 load here. So 1.4 for this particular, or we can do one thing, okay, just apply the 1.4 here. Okay, 1.4 has been applied. So like this we have applied the wind load. A little bit more research needs to be done on this wind load part. So if you find anything which that I can share with my viewers, you can just let me know in the comment section. But overall, this the design, the wind loads have been applied according to the code. So now after this has been applied, what you need to do, so dead load has been applied, live load has been applied, wind loads have been applied, and seismic load will be applied automatically. Now we need to define obviously the load combination. So define go load combination here, and add default load combination for the steel structure, and click on OK, and then click on OK. So these default load combinations are there, which are defined, and after that we go to analyze and check model to check if there is anything wrong with the model. Select all and click on OK. So our model is fine, no warnings are there. So we'll go to analyze. You can just click here or just click F5 here to analyze the model. Before that you need to save the model. I'll just save here industrial truss and then click on save. Once this is saved, you run the analysis here. So once this analysis is complete, just click on this steel frame design. It will design the steel frame, and you can let know